Hello, ib2 students. Second lesson about energy production. Today we'll be talking about solar power, hydroelectricity and wind power. I hope that you remember our last lesson. Our last lesson was about fossil fuel power plant, or about fossils, and about nuclear fuel power plants, so about nuclear energy. Okay? Today we'll be talking about three other sources, like solar, like hydroelectricity, and about hydroelectricity and about wind power. Okay, so let's prepare lesson, of course, notebooks, pens, pencils, eventual calculators. I hope you will be noting. Always you can stop movie and then turn it back. So let's start with solar power. Okay, so the source of solar energy is of course sun, or moreover thermodynamic reactions, what I said, nuclear reactions, fusion reactions in the sun's core. Okay, so sun converts nuclear energy into radiation, which travels in the form of electromagnetic waves to the Earth. Okay, we can process this energy in two ways. First device is a typical solar heating panel or solar panel. Okay, solar panel is a device which converts sun energy, solar energy from the sun, into thermal energy. Okay, so we can use this thermal energy to, I don't know, for domestic shower and save electricity. We have heat. Practically solar panel heats up a liquid, so we have hot liquid. Okay, and second is photoelectric cell. Photoelectric cell is a device which converts solar energy into potential difference, so into electrical energy. Okay, currently the efficiency of this process is maybe not huge, but is enough to power up your calculator or others, and in some applications there are farms of photoelectric cells which can produce a huge amount of electrical energy, which is able to power up a small city. Okay, so practically we have two methods: by solar panel, which converts solar energy into thermal energy, and photoelectric cell, which converts solar energy into electrical energy. Is it clear? Okay, what are advantages and disadvantages of solar energy? First, the biggest advantage, the source of energy is free. There is no fuel cost. Okay? This is a huge advantage. Okay. Second, there is no CO2 production. We have no burning process. Okay? And in the case of disadvantages, of course, it depends on the weather. Yeah? If there's a cloudy day, depends on the weather. In cloudy day, it cannot be utilized. And second, it depends on the daytime. Okay, so at night, it cannot be utilized. Okay, is it clear? So no problems with solar energy. It's simple. Okay, so let's talk about second type, hydroelectricity. Okay, hydroelectricity is related with conversion of energy stored in the flowing water. In the rivers we can build dams, and this energy of flowing water can be converted into electricity. Is it clear? Okay, so let's imagine that you have a high reservoir of water and low reservoir of water, and water flows from high reservoir to low reservoir, and the height difference is h. Okay, what is the power of such system? Power is potential energy of water which falls over time. Is it clear? And potential energy is related with mass of water which falls in unit time. But mass of water can be written as density of water times volume of water over time. So finally we have expression like density of water multiplied by gravitational acceleration times height from which water falls times something like delta V over T, which means what is a volume flow rate of water. If bigger flow rate of water, then more bigger the power of the system. If less volume flow rate of water, then less power of the system. Okay? So here I have a first equation that power of hydroelectric system depends on density of water, gravitational acceleration, height from which water falls, and flow rate. Flow rate means what is the volume which flows in unit time. Okay, what are advantages, disadvantages of such system? Again, source of energy is free. We have no fuel cost. Okay, this is advantage. Okay, second, no burning process, so no CO2 production. The same as in the case of solar system. Okay, what are disadvantages? Okay, the biggest disadvantage is fact that if you want to build a dam, yes, you must destroy a landscape. Okay, you must destroy an environment. You must build something and change a river. Okay, so in your Tsokos, as the biggest disadvantage of hydroelectric power, you have obviously nothing. Yes, no, it must be very dependent on location, requires drastic changes to environment. Okay, so let's copy this, drastic changes. Okay, drastic changes to environment. And of course, source of energy is free, but it's very high initial cost of installation. This is also huge disadvantage. Okay? And in the case of hydroelectricity, I'm going to talk about, few words only, about something like pumping storage system. So still we are in the point of hydroelectricity. But about pump storage system. Okay, this is system of storage of energy in the form of potential energy of water. Let's imagine that you have two reservoirs, upper reservoir and lower reservoir. And when water flows from upper to lower, it delivers, let's say, P of energy, power of energy. Let's imagine that this power is 100 of units. Doesn't mean which units. And let's imagine that our system is 100% efficient, which means that if we want to pump water from lower reservoir to higher upper reservoir, still we need 100 units of power. Okay? So what for? What is the sense of pumping water from lower reservoir to upper reservoir to store it? Let's imagine that you have a city. Okay? Okay, and city uses different amount of energy depending on daytime. Let's imagine that during day it consumes 150 and at night it consumes just 50 units of energy. So a plant which delivers 100 units of energy, 100 units of power, is not enough to power this city because the peak consumption is 150. So what happens? Let's look. At night, when water falls, yes, 50 units of power is delivered to the city, and 50 units of power is used to pump water up. What for? Because if you have a power plant which produces, let's say, 100 units, yes, at day it can deliver 100 units to the city, and falling water also can deliver this amount which is needed, this amount which is a difference to the city. Is it clear? So again, let's imagine that you have, wait, let me explain it again. Let's start with the city, it will be better. Okay, so let's imagine that there is a city which needs at day 150 units and at night just 50 units. And there is a power plant which produces 100 units. Okay, so how it works? At night, I'm going to use the blue color. At night, power plant delivers 50 to the city and 50 to pump up water from lower to higher reservoir. Okay, at day, power plant delivers 100 to the city, which is not enough, but pumping storage system can release 50, which can be also delivered to the city. So it works. At night we have 50 because rest is used to pump up water from lower to higher reservoir, and at the day we have 150. Power plant delivers 100 and 50 is from falling water from upper to lower reservoir. And this system, the system of store of energy in the form of potential energy of water, is known as a pump storage system. Okay? So we are talking about solar energy and hydroelectricity. And last, today, so point number 3, wind power. Okay, what is the origin of wind? Wind blows because there is the change in pressure in different regions. And change in pressure is a result of change of temperature. And change of temperature is the result of fact that some places are heated up by sun differently. So at the beginning of the chain we have a sun. Sun produces wind on the earth. And blowing wind has a kinetic energy. Okay, let's imagine that you have a windmill. This is my windmill. Okay, through which air particles in the form of wind travel. Okay, let's imagine that in unit time, okay, these particles travel a distance of x. Is it clear? And of course, distance x depends on the speed. Let's imagine that the unit time is 1 second. If the speed of the wind is bigger, then x is longer. If speed of the wind is lower, then speed is lower. And let's try to find the maximum vertical power of windmill. Okay, so what is a power? Power is energy over time. What type of energy? Of course, kinetic energy over time. How to write kinetic energy? Of course, half of mv squared divided by time, of course. I'm going to write this in a little bit different form, mv squared over 2t. Okay, what is the m? Well, m is mass of air particles which travel through the windmill in time t. I'm going to replace this by product of density and volume of this cylinder. Okay, v squared over 2t. Capital V is volume, small v is speed. What is the volume of this cylinder? Is surface area, so other words, the area covered by the blades of the windmill, times x. What is distance over time? It's of course speed. So finally, maximum theoretical power can be written as half of density of air times area covered by the blades times speed of the wind to the power of 3, where area covered by the blades can be written as pi r squared, when r is radius of the blades. Okay? So what is important here? Important is that power of the windmill is proportional to third power of speed. So if speed of the wind increases by a factor of 2, then power increases by a factor of 2 to the power 3, so by a factor of 8. Okay, why is it maximum theoretical power? This is because in this equation all moving particles should be taken by the windmill, which is not possible. Some particles travel between the blades. Not all particles hit the blades. Is it clear? So this is maximum theoretical because it's not possible. Always some particles travel through the windmill. How to solve this? Let's imagine that this is our windmill and wind blows here. Okay, the left part of the windmill we have air of density ρ1, speed v1. Some particles of course pass through the blades, so after the windmill we have the density of ρ2 and speed of v2. So how to find the real power extracted? You have to calculate P1 before, P2 after, and power which is extracted is difference between P1 and P2. Is it clear? So again, new slide, I'm going to repeat it. In a real situation, you have to solve it in this way. This is the windmill, this is power before, P1, this is power after, P2. Power before is given by half of density before, area, speed before to the power of 3. Power after is given by half of density after, area covered by the blades times speed after. So power extracted by the windmill is P1 minus P2. Okay, advantages. The biggest advantage of using wind power is again source of energy is free. Okay, no fuel cost. Okay, second advantage is fact that we have no burning process, so no carbon dioxide production. Okay, and disadvantages are noisy. Yes, this is disadvantage. Okay, you can write kill birds, but you don't need to write this. It's also disadvantage. Okay, another disadvantage is that a large area must be covered. To obtain sufficient amount of energy. Okay, so we need a lot of windmills on large area to produce sufficient amount of energy. Okay, and of course third disadvantage depends on the weather. Okay, so today we were talking about 3 sources, renewable sources of energy. About wind power with equation, about solar power, about 2 methods, and about hydroelectricity about with equation and with pump storage system. Okay? Your homework. Open your SOCOS on page number 327. Okay, and your task is to solve exercise number 3, exercise number 4, 5, and 6. These 4 exercises, SOCOS, page number 327, exercise number 3, 4, 5, and 6, is your homework. Okay, and for next our lesson, so let me check. We have next standard level lesson at Tuesday. So you have to finish this at Monday. Yes, for Monday in 4 days. So you have 4 days to solve these 4 exercises from your SOCOS. Okay, thank you for your attention. I'm waiting for comments and see you next time. Bye.